All right, hello. Well, thank you everyone for joining us today. So today is our fourth webinar in celebration of DD Awareness Month. Go ahead, grab your moon pies, get your sun chips, get your Capri Suns, because today we're talking about the solar eclipse. My name is Kelly Jacoby. I am the Community Relations Specialist here at Delaware County Board of Developmental Disabilities. And a little bit of housekeeping before we get started. As usual, we will be recording today's session, so you will be able to reference that back at a later date. We also will always have time for questions at the end of the presentation. If you are joining us on the Zoom webinar, please utilize that Q&A box in the control panel. And if you're joining us on Facebook Live, welcome. Please utilize the comment and chat section there on Facebook. We will be monitoring both of those throughout the presentation and be able to ask those questions that you have at the end. We are excited to have Don Stevens joining us today. Don is the resident astrophysicist, director of Perkins Observatory, which is located here in Delaware County, and a self-acclaimed avid eclipse chaser. So speaking more on the observatory and specifically information on the solar eclipse, which is occurring on April 8th, I will go ahead and pass it over to Don. Thank you for being here.
All right, thank you. And I do apologize for if there's echoing and things like that. I'm at the observatory, and fortunately this little building does not have great acoustics. And I'm in a place where I'm getting a decent kind of signal here to be able to connect. So I do apologize for that. Hopefully everyone can hear me clearly. Yes, I'm with Perkins Observatory up here in Delaware. And some of you may know we do public programs, particularly on Friday nights, where we have the public come, and sometimes we do viewing with telescopes. Other times, when it's too cloudy or rainy, we do a talk and a tour of the observatory. So if you're looking for something to do on a Friday night, come check us out. Tickets are $10 each, and just give us a call. And happy to sell you some tickets for one of those programs. But I'm probably here to talk about, of course, what everyone's excited about. That's the eclipse coming up here in April. And so let me get my screen going here, and we'll get started. So hopefully everyone can see that okay. So first, I think what I should do is, not everyone might be aware of what eclipse is exactly, or what's going to be happening, why eclipses occur, that kind of thing. So allow me to go over some brief things about eclipses in general. First thing is, there are two main kinds of eclipses. There's a lunar eclipse and a solar eclipse. A lunar eclipse occurs when the moon passes through the Earth's shadow. In other words, the Earth comes between the sun and the moon. And a solar eclipse is when the moon passes between the sun and the Earth, casting its shadow upon the Earth. Now, the thing about lunar eclipses, you can see one from Ohio roughly about every 2 years or so. You just have to be on the same hemisphere as the moon is when it's eclipsed in order to be able to see it. Solar eclipse is a little bit different. You need to be in specific places to see an eclipse, in part because the moon's shadow as cast upon the Earth is very small. And I'll go a little bit more into that here in a moment. Now, there's not an eclipse every new or full moon, and that's because the moon's orbit is slightly tilted relative to our orbit. So most of the time, the moon's shadow misses the Earth, or the Earth's shadow misses the moon. And so it's only in special sort of times that you get an eclipse. And that occurs because the moon's orbit precesses, we call this precessional wobble, like the top here, as you can see. And only when the points where the moon's orbit crosses the Earth orbit, we call those nodes, when those line up with the sun, do we get eclipses. And there's actually a cycle to this. It's called the stereo, which means regular. It's roughly about 18 years, 18.6 years for this cycle. We've known about it since ancient times. Another thing that plays a role in eclipses is the distance the moon is from the Earth. The moon's orbit is not perfectly circular; it's elliptical. There's a point where it's close to the Earth and a point where it's far away, in other words. And it's responsible also for the phenomenon that's often referred to as supermoons. And these occur basically every month. right? Every orbit, there's a supermoon. It's just not always on a new or full moon. So chances are you go out and look at the moon regularly, you're going to see a supermoon. It just might not be during, again, a full or new moon that occurs. We add up all these various cycles and patterns of the moon's orbit up together, we find the moon's orbit is actually pretty complicated. It's not just a simple ellipse or circle. Instead, it forms kind of a torus or a donut shape around the Earth. The torus is the mathematical term for this particular kind of shape. And so this is all the orbits of the moon add up over a complete Saros cycle. Now, there's actually three kinds of solar eclipses. Most of Ohio is only going to get the partial eclipse. There's only a very narrow strip of Ohio that's going to get totality. Another kind of eclipse is called an annular eclipse. That is when the moon's at its furthest point in its orbit, it's smaller relatively in the sky, so it won't completely cover the sun during an eclipse. And you get this kind of ring, it's often called a ring of fire eclipse. There was an example of this actually back in October. I believe on the 14th of October, if I remember correctly, and it was visible out west. Unfortunately, here it was cloudy, so we would have been able to see a partial. I do know a couple of friends of mine got a peek through a couple of gaps in the clouds to see the partial, but unfortunately, it was mostly cloudy over Ohio, so we didn't get a chance to see it. And then there's, of course, the total eclipse. This is what we're getting next month. Now, throughout history, eclipses have, inspired fear and reverence and awe in many different cultures, and many cultures have their own explanations to what caused the eclipse. In particular here, the Chinese believe that a dragon was consuming the sun. And what they further believed was, well, of course, it's not a great thing to have a dragon swallow your life-giving sun, your life-giving sun god. So they would go out and try to scare the dragon. They would shoot arrows in the sky, they would bang pots and pans, drums, blow horns, trying to scare the dragon to release their sun god. And this worked every time. Now, eclipses have also had political consequences throughout history. A good example here is called the Battle of the Eclipse that occurred May 28th, 585 BCE, about 2,500 years ago. And it's also called the Battle of Halys. It's in Asia Minor, which is modern-day Turkey. It may have been the first correctly predicted eclipse. We're not 100% sure, in part because Thales Miletus did not record how he predicted it. And it may have been a previous eclipse to this or one following fit the predictions as well. So it's not 100% sure this was actually predicted by him. Combatants, by the way, were the Medes and the Lydians. They were both fighting for domination of the Asia Minor Peninsula. When the eclipse happened during the battle, they freaked them out. It scared them. They thought they'd angered the gods, so they quit fighting and immediately went home and negotiated a peace. Another interesting thing related to eclipses is something that was discovered 100 years ago, like on a shipwreck, something called the anti-air mechanism. And this device that they found at the bottom of the ocean, which dates roughly from around the 2nd or 1st century BCE, by the way, the shipwreck does, contain gears and levers and dials and inscriptions that seem to indicate its function, possibly the world's first actually analog computer. This is a reconstruction of what it probably looked like. They were able to figure out the gear ratios and things of that nature. And what they found was this was able to accurately predict the position of the sun, moon, and planet. It would set their initial observed positions, and you turn this crank, and it would spit out, where the sun, moon, and planets were in the sky months, years later. And it was also able to predict eclipses. One of the inscriptions, in fact, on the device is the word Saros, again, for regular. And one of the gears has the gear ratio seems to be related to the Saros cycle itself. Now, an important eclipse as far as Ohio, in fact, the last eclipse occurred in Ohio was back in 1806. And this also had some political consequences. It's often referred to as Tecumseh's eclipse. He and his brother, who was nicknamed the Prophet, predicted this eclipse and used it to unify the tribes against the invading Europeans. Now, what in reality probably happened was missionaries had taught Tecumseh and his brother how to read, and they got their hands on a farmer's almanac, which had this eclipse predicted in it. Now, as mentioned, I'm a little bit of an eclipse chaser. I'd like to talk a little bit about my experience to kind of let you know what to expect yourself if you decide to try to chase this eclipse, to actually view it. This goes back to 2009. There was an eclipse in Asia. You can see it travel over India and China into the Pacific Ocean and across the southern islands of Japan. And I initially was planning on going to Shanghai, which is right in the eclipse path there. But when my flight landed in Tokyo, I was catching a connecting flight from Tokyo to Shanghai. I looked at the weather forecast and it did not promise it looked like it was going to be raining through the eclipse path in China. I could have tried to go deeper into China, but I wasn't going to risk it. It would have been very difficult to do. So instead, I opted to try to get to these little islands here in Japan that lie between Okinawa and the main islands. These are called the Ryukyu Islands. Most of them are little resort islands. So I managed to catch a flight to Okinawa. And from there, I tried to find a way to get from Okinawa up into these little islands. Because of the timing, I only had like a day or so before the eclipse, and I could take a ship. The ship or boat would have taken 2 or 3 days actually to get up into the eclipse path from there. Even though it doesn't look very far, it actually is quite far. And so that left flights, but unfortunately, all the flights were booked. So I'm sitting there in the airport lounge, kind of depressed, not sure what I was going to do. Struck up a conversation with the guy sitting next to me. Turns out he is a pilot that flies the mail to the islands, those little islands up there. And so I managed to bribe him to leave a little bit of mail before he carried me and my equipment up to one of these islands. I get up to the island, and just a matter of hours before the eclipse is due to start, managed to secure a room and then get the Uber equivalent up to the north end of the island, because the closer you are to the center line of the eclipse, the longer duration you get. So I was trying to get up to the north end of the island. I got up there, got my equipment set up, started taking pictures, get all the way to here, and as I'm taking pictures, where to be a picture of what I'm doing, I have a hood over me to keep the screen darkness around where I can see the screen well. And I'm taking pictures, and suddenly the image after this one disappears. I thought, oh no, my battery died or something. No, the camera was still functioning, taking pictures. Did I bump the telescope? No. Maybe it's someone standing in front of the telescope. So I take the hood off, drip, drip, drip. It had clouded up and started to rain. And unfortunately, it rained through totality. So I missed it. However, that night, I'm sitting on the beach there, this little resort island there in the Pacific Ocean, very beautiful island. Population of about 400 people. The island is roughly about the size of Delaware County or Franklin County. And but only 1,200 people, so it's very dark there. And so I'm sitting on the beach, you can see the Milky Way all the way down to the water. The water was very calm, almost like glass. You can see the Milky Way reflected in the water. And I'm like, okay, universe, I'll take this, but I want the next one. Well, the next one was the next attempt I made. And this one, of course, was not over Ohio, but it was across most of the U.S. and made it relatively easy to get to. Most folks I know went down towards Kentucky and Tennessee. I decided to go all the way to Wyoming, where it had the best probability as far as cloud cover. And so I get set up, and this is actually on an Indian reservation that's east of Yellowstone. Got my equipment set up there. And what's great about these is you often can run into people from all over the world. You know, there's a lot of people that chase these things all over the world. In fact, the couple next to me there in the hats were from New Zealand. And it was quite interesting talking with them and such. And as always, I had my little traveling companion there, Neutron the Anapter dog. You can see him underneath the mylar tarp there. I'm using to keep shade for him to stay cool. And this is what I got. This is totality from 2017. And it was very, very beautiful. I was very lucky to be able to see it. But what the moment that people like me wait for is this. This is called the diamond ring effect. This is when the eclipse is about to end, totality just begins to end. The sun starts to emerge, basically. The moon's surface is not perfectly smooth, of course. It has mountains and valleys and craters and things like that. And you'll get this first peak of sunlight coming through one of those valleys, kind of like the first peak of sunlight through a valley here on Earth at sunrise or the last at sunset. And it's very, very beautiful. And this is really, for me, what makes the eclipses worthwhile worth seeing is this diamond ring effect. Now, the other thing you'll see, of course, when we go back to this picture, is you'll see this glow around the moon. That's the sun's atmosphere. It's called the corona. It's made of 2 million degree gas, and it glows about as bright as a full moon. So during totality, it never gets completely dark. It's going to be more like twilight at totality. If you plan on tasting these things, here's just the basics, right, to get you started. Plan ahead, you know, make a plan where you're going to go, things like that. Have a backup plan. And as I learned the hard way, have a backup plan to the backup plan. Because things can always go wrong as well. Pack lightly, be mobile, so that way you can grab your stuff and go. And then if you're going to take pictures, rehearse ahead of time. But I strongly recommend, if this is going to be your first eclipse, don't waste your time trying to take pictures. Enjoy the eclipse, enjoy the experience. Because if you're fiddling with your camera or your phone or something like that, you're missing it. All right, you're missing the experience. So just don't waste time doing it. Just watch it. All right. But again, lesson learned, be prepared for failure and make the trip fun. And I did, even though I missed the eclipse, I got some enjoyment out of that trip. I spent great time in Japan for a couple of weeks. It's a beautiful country, lots of history and scenery and things like that. People are wonderful there. So make it, if you're planning a trip to see an eclipse, make it worthwhile by doing other things that you enjoy doing. Now, as far as eclipses, this is an example of what an eclipse looks like from space. As you'll notice, as I mentioned, is not very big on the Earth, all right? You have to be a very specific place. And the motion of the moon's orbit and Earth's rotation play a role in the duration of the eclipse. Okay, because the Earth is rotating as the moon's going around. And so as you see, as the moon shadow travels across the Earth is moving, and that influences, again, the duration. Here's an image from ISF 2017. I'm somewhere in that shadow. That's the western US, where that picture was taken, I believe. Excuse me. Now, as far as the blade eclipse, what to expect? Well, first, the eclipse actually starts over the Pacific Ocean, and the shadow travels thousands of miles an hour across the Earth's surface, and it comes into Mexico, then crosses the US-Texas border, and then eventually up into Ohio. The whole thing only lasts a couple hours, but in any given location along the eclipse path, the totality path there in yellow, the eclipse duration is actually only a couple of minutes usually. And where you see the kind of the gray shadow around the eclipse path, those are where you get partial eclipses. Now, in detail, this region, you see here the eclipse path, and it comes into Ohio roughly about 308 is when it begins to cross into Ohio. And then by 319, it has crossed the state border and out of Ohio. So it's only in Ohio for a few minutes. And again, you got to be specifically in the eclipse path to see totality. As you notice, there are several cities, communities in the eclipse path, but some aren't. For example, most of Cincinnati, most of Columbus are not in the eclipse path. Only part of Hilliard, Dublin, Powell, and Westerville are actually in the eclipse path. And the other thing is, the closer you get to the center line of that eclipse, the longer duration you get, right? Like, for example, in Dublin, you're going to only get about a minute. In Delaware here, we're going to get anywhere from 2 to 2.5 minutes. And, you know, as you get up towards Lima, you get over 3 minutes. In Cleveland, you know, over 3 minutes as well. So it doesn't matter where you are as far as how long the eclipse you're going to get. All right. Now, in detail, if you're planning on going somewhere to get in the path of totality or get closer to the center line, here's a map showing the major roads that are in the eclipse path. There's a little bit of 70 there, cutting across through Dayton, and then 75 running between Dayton up to Toledo, 71 between north end of Columbus and Cleveland, and the turnpike going across the north end of the state up there. A little bit of 77 up in the Canton, Akron area. But for the most part, it's pretty rural. Particularly the counties that the center line goes through are pretty rural counties. So roads are going to be very difficult to travel on the day of the eclipse. I've been working with the state of Ohio and Delaware County as on an advisory role of planning for this. And they are estimating the population of the state that weekend might get close to doubling. Why, you might ask? Well, let's go back to this map. If you look at major metropolitan areas that aren't in the eclipse path but are near Ohio, such as Detroit, Chicago, Fort Wayne, Lexington, Charleston, Huntington, Parkersburg, Wheeling, Pittsburgh, and even further east, the way this eclipse path travels across the country, most of the population in the United States is on the east path. So people are coming from the east, you know, as far away as Baltimore, DC, New York, Philadelphia, probably coming to Ohio. And so there's going to be a lot of people here, and there's even people coming from all over the world. So traffic is going to be very, very difficult at best on the day of the eclipse. Now, here's where I get to be Debbie Downer, you know, the realistic expectation, that kind of thing. What's the probability of being able to actually see the eclipse here in Ohio? This is a climate model, cloud model based off of about 4 decades worth of data and modeled between April 1st and April 15th. And in June, and what is the probability of having clouds on April 8th? And as you can see, most of Ohio in the eclipse path falls in the 80 to 90% range. Okay, there's a little bit of near the lake, if it happens here over the lake. Lake effect clouds tend to form a little inland, so right near the edge of the lake, there's a little bit better probability of clear skies. But for the most part in Ohio, the chances are pretty small, unfortunately. The further south and west you go, the probabilities are higher. So fear not, though, if you miss this one for whatever reason, there are other eclipses that happen. They happen every couple of years. Just not in the United States usually. The next one is in August 2026. That catches a little bit of Europe there in Spain. But for the most part, it's over the North Atlantic and Arctic, which that time of year is usually pretty stormy and cloudy. So, yeah, I don't know if I'll be bothering with this one or not. If I do, I'll probably wind up in Spain. The next one after that is in August of 27. That is through North Africa. in part of the Middle East, things going on there. I don't know. Just kind of have to see how the political situation is in that part of the world. The one I'm most likely hedging my bets on is going to be the 28 one in Australia, across Perth and through the outback there. It's usually pretty dry that time of year. So I'll try that one probably. And then there's 30 through South Africa and Australia again. If you want to leave the US, well, you're going to have to wait 20 years for the next one in the US. 2044 catches a little bit of Montana and North Dakota. 2045 is the more ideal one. It goes from California down through Florida. And then there's one in the 50s, a couple in the 70s. The next date for Ohio is 2099, September. Mark your calendars. And the path is a little bit bigger in this case. It's going to cover most of the state, so it should be a pretty good one for the folks that are around that. Let's talk about safety. We want you to view this safely. Hopefully, you've got your hands on Eclipse glasses for this eclipse. If you haven't, so we do have them here at the observatory currently for sale for $2 a pair. Just give us a call and I'll schedule an appointment to meet you to get you some Eclipse glasses. If you're going to take the chances of buy them online, be very careful. For example, in the 2017 eclipse, the community in Kentucky bought about 60,000 pair from Amazon, and they turned out to be counterfeit. In other words, they were unsafe to use. So even though they ordered them from Amazon, they had to shred the whole lot. So what I recommend if you're going to try online is first go to the AAS website. That's AAS for the American Astronomical Society, not the American Astrological Society, the American Astronomical Society. And they are the ones that are certifying eclipse glasses. They partnered with several manufacturers and distributors and retailers to get safe glasses out to the public. So I recommend going through their site if you want to buy them online. Go there first and go through one of their links. Other viewing methods in a pinch, you can do the old-fashioned pinhole method. And that is where you basically have a couple pieces of, I recommend poster board or foam core. And what I usually do is cut like an inch hole in one of them. And over that hole, I tape a couple of layers of aluminum foil and a little bit of cellophane over that. And take a little needle and poke a tiny little hole in that foil. And then hold another screen about a meter or 3 feet back to project an image of the sun. Of the eclipse. This is the safest method aside from glasses that we recommend doing. You can use a telescope, however, it can be a little dangerous, and what we recommend is using front-end solar filters. Don't use eyepiece filters. All right, it's very dangerous. Just don't do it. You want to filter the light before it comes into the telescope. And there are two kinds. One's made of kind of a mylar material, similar to what the eclipse glasses are made out of, or you can get ones that are made of glass. Of course, they're going to be a lot more expensive. And be sure you buy one specifically made for your telescope. Do not try to kludge something together. Use the proper equipment, because any light not filtered coming through that telescope is going to be dangerous. It will burn your eyes, destroy them basically, and it can destroy the telescope as well. All right. In fact, if you can use the telescope to just project an image, but this is dangerous, right? Because the eyepiece is going to get very hot. Basically, it's like putting a magnifying glass there. And if you hold something too close, it's going to catch on fire. The other thing is, telescopes, of course, are usually made for looking at the night sky, things that aren't bright, like the moon and the planets, things like that. They have special coatings on the lenses that make the images, crisper or better. This is going to destroy that coating. And some of the telescopes more cheaply made have plastic lenses, not glass, and that's going to melt or distort those lenses. And I've even seen eyepieces get hot and shatter. So, and basically after doing this, the telescope's going to be junk. You're going to have to throw it away. So I don't recommend doing it unless it's a cheap telescope that you don't care anything about. So normally I had questions at this point. Instead, what I want to do is, before I take questions, I want to jump into, let me switch screens here real quick. I'm going to pull up a piece of software to simulate the night sky, or not the night sky, the eclipse, and show you what to expect roughly. All right, don't pay attention too close attention to the times on this, because depending on where you are, the times are going to be slightly different. So you can look online to find specific timings for your area, which is what I recommend doing. So, but roughly, a couple minutes or so before 2 p.m. is when the partial phases start, and that's the point we call first contact. And what you will see is slowly, you see a little bite out of the sun. And again, you're going to be wearing eclipse glasses, by the way, at this point. All right, so not looking directly at the sun unless you have the eclipse glasses on. And then you'll see this little bite out of the sun as the dragon begins to swallow the sun. Words. And over about the next hour, a little over an hour, the partial phases. So this is often a lot like watching grass grow or paint dry. But the other thing is, you won't really notice it getting dark yet. All right, even though the sun's getting covered up, it's not going to dramatically change in brightness until we get relatively close to this point. You're going to start noticing in brightness. Also, pay attention to what's going on around you. Shadows are going to begin to look weird. It's hard to describe in words what it does to the shadows, but it's just something, again, you got to experience for yourself. Animals will begin to react to this. Cows, if you're near like a cornfield, or not a cornfield, a cow pasture, the cows will lay down like it's night, it's getting night. The birds will start to roost. If there are crickets out, you'll start to hear crickets. And slowly, as we get near totality, it starts to get darker and darker. And the other thing you're going to do is watch near the horizon. You actually will see the moon's shadow approach. You'll see the moon's shadow coming from the southwesterly direction. And you'll actually see it. It's really cool to see the shadow moving through the atmosphere as it approaches you. And then right at this point, when the sun disappears through the eclipse glass, where you can't see it anymore, that's when you take the glasses off. Because if you don't, you're going to miss this. All right? This is totality. And what you're seeing is the sun's atmosphere here, again, called the corona. And it's about as bright as a full moon, as I mentioned before, and you won't see it through the eclipse glasses. And it's perfectly safe to look at this. There's a lot of mythology out there on the internet about eclipses, claiming that you should never look at eclipses, that this is dangerous. It is not. All right, this is a professional telling you. It is safe to look at this point. All right, when the sun is completely covered by the moon. And then for however long duration is at your location, you can leave the glasses off and look at this. And you're going to see why people long ago were fearful and in awe of this, because the software is not doing it justice, believe me. And then at the last second, you'll get that diamond ring effect. All right. That, again, you can look at it with your eye briefly. It only lasts a few seconds. And then you put the glasses back on. All right. And then if you want to watch the partial phases, again, you have the glasses on at this point. If you want to stand around the next hour or so and watch the end of the eclipse, Usually at this point, people like me, we're throwing our equipment in our car and saying, okay, when's the next one? So, and then for Ohio, it's roughly going to be, the first phases will all be over around 4:30 or so. So that's pretty much the eclipse and what to expect. So if folks have questions now at this point, I'm happy to field questions. So
Awesome. Thanks, Don. So while we are waiting for our questions to come through, we again can have those in the Q&A box in the Zoom control panel and then on the chat feature on Facebook Live. So while we're waiting for those to start coming in, Don, where are you watching the eclipse this year? Where are you heading?
I'm basically heading southwest. I don't know exactly where I'm going to wind up. Again, it's all about that being, mobile and just what I'm going to do is camp somewhere near the eclipse path down probably towards Texas or something like that. And, decide then where exactly in the path I'm going to go. I'm not leaving until, a few days before the eclipse. So I'm watching the weather. If it looks promising in Ohio, I might stay in Ohio. So there's still a chance I'm going to be in Ohio, but most likely I'm not, based off, again, that cloud cover prediction. So first question, should we keep pets indoors? Well, pets are a little smarter than humans in this regard. They don't look at the sun. Basically. So, it doesn't matter. You can have them outside, they're not going to look at the sun. Do you know the locations in Delaware County to get glasses? I know there were some places that were giving out glasses and stuff like that. I don't know now. I think a lot of the places that have given out the supply they've had.
Yeah, I can speak to that a little bit. I would say if you're in Delaware County, reach out to the health department. If you are with us here at the Delaware County Board, you can reach out to your service and your SSA as well as your service coordinator. We do have some glasses that we received here at the county board.
Yeah, and the other thing I would like to say in that regard as well is, as far as the free glasses being given out, if you can afford to pay for them, you should. Leave the free glasses for folks that are not as financially capable of getting glasses like from online or something like that. And so we're only selling for $2 a pair. If you can afford that, do it. I mean, yeah, it's a little selfish because we want to raise some money, but yeah, I try to save those free glasses for other folks. Next question says, how much time from beginning to end? Do you mean totality? Because it's going to vary depending on where you are in the eclipse path, and where exactly you are in the eclipse path. So that's something you need to look online for your specific location. You can look at the eclipse timing. And as someone asked, what's risk for pets? Well, again, there's no risk because animals are not going to go out and look at the sun. They're just not wired for that.
How much time, Don, from beginning to end, from when the path even starts?
Well, from first contact to last contact here is roughly 2.5 hours or so. And bear in mind, when first contact happens, that's when the moon shadow is beginning its journey across the Earth. It's starting over the Pacific Ocean at that point, and it's traveling thousands of miles an hour along the eclipse path up towards Ohio.
We had somebody reach out about if there's a temperature change.
Yeah, that's another thing that'll happen during totality. And this, even if it's cloudy, you'll still experience the eclipse. You won't see it, but you'll still experience it. It'll still get dark street lights will come on, and there will be a temperature change. The temperature can drop a few degrees, and sometimes they'll even start like a light breeze from the temperature differentials because it changes so quickly. So yeah, even and I like to, there's some folks out there, of course, who can't see, that they're blind, or their eyesight's terrible. They can't see, but you can still experience this indirectly by, the feeling of it, from the temperature change, the wind kicking up, and the sounds of nature around you. You'll hear the birds begin to roost, you hear crickets and things of that nature. So even if you don't have sight, you can still experience this.
We did have a question come through on our Facebook page about they read some information that if a group of people should all wear blue or green for the best experience.
I don't understand what, the color you wear would have influence on the eclipse itself. I honestly, there's some weird stuff on the internet being claimed about this eclipse, stuff like that. So yeah, it does not matter what you wear.
Awesome. So we did have a webinar earlier this month with the Columbus Zoo and Aquarium, and they were mentioning that they're excited to see, during the eclipse, what the reaction of the animals are at the zoo. Do you have, I know we talked a little bit about our personal pets and how they might react. Do you have any insight on maybe how some of our zoo animals might react?
That's an interesting question. I guess what would happen is, um, the again, the animals that generally aren't nocturnal, they're gonna feel like they're gonna need to settle down for the night. And then nocturnal animals might become a lot more active for that few minutes.
Yeah, it'll be interesting to see, I guess.
Hopefully they like record it or something and share it with the public. That'd be great.
Yeah. I know at the very beginning of your presentation, you talked a little bit about kind of the history and how we found how even, back in the Mayan times, I think you said it was what, 15 or 536 BC or something. How,
Oh, the Battle of the Eclipse that occurred there in Asia Minor, yeah.
yeah, how do modern scientists predict the eclipse? How did they predict it back then?
Well, again, it basically just came down to observing the cycles and patterns. Starting as far back as the Babylonians and Mesopotamians were some of the first to make astronomical observations, and even further back. For example, they found bones at archaeological sites that date tens of thousands of years ago that have the moon phases marked out on them. Someone carved moon phases in a bone. So humans for a long time have been noting patterns of nature, and by just again regular observation, then you can work out how long these cycles happen. And then once you know that pattern, you can make a prediction then in the future. Like, well, okay, there's going to be this happen, so many years from now, things like that.
Awesome. We did have a question come through in our Q&A. They said, you said it would be like twilight during totality. How many minutes before or after totality will it be dark, where the lights might need to be on in your car, etc.?
Just a few minutes, maybe 10 minutes at most. It'll be dark enough to where you need headlights. With it being cloudy, maybe a little sooner. Maybe 15 minutes or so, 20 minutes. But it's going to be a relatively rapid change in brightness over that period of time.
And you had mentioned that you're on an advisory board regarding safety for the eclipse that's coming up. Can you speak a little bit more about the traffic? Should people be prepared to not travel that day? How bogged down do you think traffic will get? I presume, right before and right after the eclipse, but any other discussions that you guys had regarding that?
Well, basically in 2017, for example, I had friends, I went to Wyoming, I had friends that went down to Kentucky. That's about a 6-hour drive down there, but it took them more than 20 hours to get home. They estimated that after the eclipse, there were more than 25 million vehicles on the road. And they're estimating this one upwards of 40 million vehicles on the road. That's across the whole eclipse path, by the way, not just Ohio. But still, it's going to be quite significant. And as I showed you there are very few main roads, highways in that region. And so it's going to be pretty bad. So the philosophy they've been promoting for folks is come early, stay late. If you can get where you're going, a few days before, do that, and then plan on sticking around wherever you are for a day or so afterwards. A lot of the local communities are throwing events, eclipse viewing events with music and things like that, encouraging people to stick around after the eclipse, not all trickle onto the roads at one time to hopefully keep the traffic down. Because the other thing to keep in mind is, there are going to be emergencies, and folks, our first responders, are going to need to be able to get quickly to where they need to be. They're going to try to be strategically placed around the eclipse path in different areas, and but if we can try to stay off the roads for a longer period of time to let that congestion be a lot less, so folks that our first responders can get where they need to go, that's going to be great. All right. The other thing is, do expect cell phone service disruption, because everybody's going to be trying to want to live stream that, and post selfies and pictures and stuff like that. So do expect cell phone disruptions and things like that. For local folks, I recommend, if you haven't already, and some of the like dentists and things like that are rescheduling appointments. If you have a non-critical medical procedure, reschedule that. Get your prescriptions refilled early. And if you're going to order anything, packages, things like that, get it done now, because expect those around the time the day of the eclipse to be delayed by days. So anything critical you need, get it now. We're basically asking folks to kind of treat this like a natural disaster, like a major snowstorm or something like that. Get your groceries, things like that early. Stock up on water, whatever, to be prepared.
Would you expect a few days before and a few days after to be difficult regarding travel and shopping and things of that manner as well?
Right, yeah, and fill up your gas tank, yeah, because that's going to be another critical thing. There'll probably be shortages of gas, and expect long lines if you didn't wait. If you didn't take care of it early, expect long lines at the fuel depot and a gas station, and expect long waits as well.
Awesome. And then if you don't mind, Don, just repeating again the safety. So keeping your glasses on up until, do you mind just repeating that part?
On until you don't see the sun anymore through the glasses.
So keep them on until you don't see the sun at all, then take them off?
Yes.
See the eclipse, put them back on as the partial
when you see
returns,
the diamond ring, when you see the diamond ring, put the glasses back on.
Awesome. Let me check here, make sure we don't have any other questions on Facebook. It looks like our Q&A box is free right now. And our friends on Facebook, thanks for joining us. Looks like we don't have any questions coming in right now. Again, just a reminder, if you are here in Delaware County and served by us, reach out to your SSA and your service coordinator. We do have glasses here that we can give out. If you have any questions or anything, please feel free to reach out. Always a huge thank you, Don, for visiting and giving us all this wonderful information. I know that there is a large group of us that are super excited about the eclipse, again, coming up on April 8th. We've got our moon pies. We're ready to go in celebration of the eclipse.
Nice.
All right. Well, thank you all for joining us and for celebrating DD Awareness Month. We will see you guys soon. Keep an eye out on our website and always on our Facebook page for any initiatives that we have coming up in the future. Have a great weekend.
All right, thank you, everybody.